Hello, I am a polymer chemist who is over 60 years old and start memory loss these days. The other day, a Japanese pharmaceutical company, Eisai, announced a drug for Alzheimer's diseases. I imagine that this is a drug called Lecanemab that sucks out amyloid-β that does bad for central nervous system. I, an old polymer chemist, will leave behind a method of developing a sponge polymer that will suck up amyloid-β. I use Hansen Solubility Parameters to study what chemicals dissolve what material. In the words of Dr. Hansen, likes dissolve like, or likes seeks likes. So the question is, how does amyloid-β find a place where it can dissolve itself? Let's determine the HSP of the central nervous system. Anesthetics are used when performing painful surgery. At the time, this MAC value is very important. I assume that this value is very small. That means it is easily dissolved in the CNS. In this video, you will learn how to create a simple dataset for HSPiP. Prepare a tab-delimited text file with the compound name, SMILES molecular structure, and MAC value. This is then loaded from HSPiP. Let's do it. QSAR, select the file, calculate data, then export. Set file name. It can be loaded into the main table. Open, read. The MAC value is automatically be placed in the score column. Make sure that data point option is selected and the good is small are selected as option. Calculate Hansen sphere. We obtain Hansen sphere. The center of this sphere will be the HSP of the CNS. So, read file and export data. Export data, search Hansen sphere. Then we get HSP of central nervous system. We then put the HSP of CNS into distance scheme and examine the relationship between MAC and HSP distance. Since molecular volume and boiling point also affect MAC, the correlation is not high. But we can say that the shorter the HSP distance, the smaller the MAC. Now let's look for what other compounds dissolve well in CNS. Let's do it. Find moles, set range, 15, 16.2, 5, 8, 3.2, 6.2, and such. Then you can obtain the list. These are monomer. It can be seen that butyl acrylate has almost same HSP value as CNS. I will check the SDS. As I thought, it seems to act on the central nervous system. When the monomer polymerizes, its volume shrinks, so its HSP increases. Then it is better to search the polymer database from the beginning. Let's do it. DIY, polymers tab, and sort DD or sort DP, and search. Okay, we found it. Double-click polymer smiles. Send the polymer smiles to text field, then calculate. Then YPB calculates the polymer properties. Thus, I was able to design a polymer that has almost the same HSP as CNS. It would be interesting if a polymer design in this way could absorb amyloid-β like a sponge absorbs water. If I develop Alzheimer's diseases, I would like to take this polymer. Joking aside, I think this polymer has great potential for slow release of these drugs, actually used as Alzheimer's drug. It would be even better if it could absorb amyloid-β after the drugs are released. Thank you for attention.